Algebra 2, Unit 4, Lesson 5.2. Today we will be evaluating logarithms. So in the previous lesson, we learned what a logarithm is. And a logarithm is representing an exponential function where x is in the exponent, and you're trying to solve for that value. Okay, so they're kind of inverses of each other. So today we're just going to practice evaluating. So the first category is evaluating mentally, and this is important because if you understand what a log is, some of them are pretty easy to do mentally. But then I'll show you how we can use a calculator to help us solve it, as long as we understand when you type in a log, you know what you're solving for. Okay, so in order to do this mentally, we are first going to rewrite it in exponential form. So if you set the equation equal to x, then this log base 3 of 81, it means 3 to what power equals 81. Okay, so if you have the charts that I give out in class where it gives you like all the list of the perfect squares and cubes, we could go to our perfect cube list and look down that and see if 81 is in the list. Since I don't have a picture here, we can also just kind of guess and check. So for example, like I know 3 squared is 9 and 3 cubed is 27, but what about like 3 to the 5th, 243, so 3 to the 4th. I skipped that one, but 3 to the 4th is 81, so that means x has to be 4. Okay, so you can use the charts that I give out in class. You can also kind of guess and check with a calculator. All right, let's look at number 2. So log base 9 of 3 means 9 to what power equals 3. And so this one is kind of tricky, but if you remember the square root of 9, that is 3, right? And in a previous unit, we talked about how the square root can be written as an exponent of 1/2. So that means if we are evaluating 9 to what power equals 3, x would have to be 1/2. Okay? Looking at number 3 here, we have log base 5 of 1 over 25. So again, this one is asking you 5 to what power equals 1 over 25. This one, I don't think it's too bad, but hopefully you recognize the relationship between 5 and 25 using exponents. So off to the side here, I know that 5 squared is 25. But if I want this to be a fraction, if I want the 25 to be in the denominator, then I would need a negative exponent to mean 1 over 5 squared, which is 25. So this one is negative 2 for our exponent. Number 4 here, we have log base of 1/2. Log base 1/2 of 8, sorry. So this one is asking you 1/2 to what power equals 8. So again, if you can relate the relationship between 2 and 8 using an exponent, I know that 2 squared is 4, and hopefully we know that 2 to the 3rd is 8, or you might see that on the chart, the relationship between 2 and 8. So I need this to be 2 to the 3rd. In order to make my fraction flip, I would need a negative exponent. So if this was to say 1/2 to the negative 3rd, that is the same as 2 to the positive 3rd, because a negative would flip that fraction, right? And so there go, this would equal 8. So the exponent that we need with our 1/2 is a negative 3. So x equals negative, 3. So mentally it's a little tricky because you have to think about the relationships of the numbers using exponents. And you also need to understand the exponent rules involving negatives. So we do have a calculator to help us. On any handheld calculator or basic calculator, I think your phone calculator might even have it now, you can type in anything as long as you have a base of 10. So log base 10 of anything is written with just a log. They don't even write the 10 because it just is another thing to write, and it's assumed that the base is 10, okay? So on any handheld calculator, you can find this button. Same on Desmos, okay? So if you go to Desmos and you click, actually you don't have to click functions. You could literally just type it in, log, and then you could type in 100, and it spits out your answer, okay? But again, if you were to think about this mentally, the question is 10 to what power equals 100? As Desmos showed us, that exponent needs to be a 2. 10 squared is 100. Okay? If we look at number 2, this one's a little trickier because the answer isn't a whole number. Oops. So again, this is asking log base 10 of what? Or 5 equals x. So 10 to what power is 5? Okay? Now we know 10 to the 1 is 10. So the number has to be less than 1. But 10 to the 0 would be 1. So it's got to be bigger than 0. Meaning this has to be a decimal. So this is where Desmos is nice because you can just type in log 5. And it spits out this crazy decimal, which can't be converted to a fraction. So we're just going to list the first two, and I don't even round it. I'm just going to leave it 0.69. Okay. Number 3, this is representing the natural log, which we will talk more about in a future lesson where this comes from. But a natural log is represented with ln. It's so common that it is also on any calculator, and on Desmos you can just type ln, and then you can type 2.71828. So our answer here is going to be 0.999. So it's basically 1, pretty close to 1. Okay, so number 4 is the same idea here. We can just type ln 0.1. And so we know our answer is negative 2.3. That's the exponent we would need. Okay, so again, any calculator can do log base 10s or natural logs, which is represented with the ln. So what if the base is not 10? Or it's not a natural log? So in order to solve anything with a base that's not 10 on any given calculator that has just log or ln, you're going to use this change of base formula, okay? And the formula is you're going to do the log of the big number, which is b, on top, and you're going to divide it by the log of the little number, which is a, on the bottom. And this will get you your answer, so it should work on any calculator. Desmos, a handheld, doesn't matter. Okay, so let's practice that using our change of base formula. So if we have log base 4 of 7, again, this is asking you 4 to what power is 7? I know 4 squared is 16 and 4 to the 1 is 4. So we're somewhere in between 1 and 2, meaning it's a decimal. So we need a calculator, right? Okay, so change of base says if we typed in log 7, the big number, and then divide it by log 4, the little number, it will give us our answer. Okay. So again, you can just type in log. Oops, I missed the O. 7, and then divide it by log 4. And so the answer for this is 1.40. Again, I'll list 2 decimal places, but I do not round. And there we have it. okay? But you guys have access to Desmos, and Desmos has updated their calculator to have logs of any base. In order to get this to work, you need to hit the functions button. And it pulls up like your trig functions, your stats buttons. If you keep scrolling all the way down, oops, I might have went too far. Oh, it's underneath calculus. Okay, so these formulas are used a lot in pre-calc and calculus. But if you see, we have our ln, which we can just type that in. We have log, we type that one in. But you also have this log base a. And so it sets it up to where you can type in the 4 for the base, so it's little. And then you can type in the 7 in the parentheses, and you'll get the same answer, okay? So the change of base formula works for any calculator. Desmos has logs of any base. So if you forget the formula but you have Desmos, that is okay. Just in case you don't have Desmos, change of base always works. Okay, so let's try the second one here. This one is asking 3 to what power equals 15. Again, this is probably going to give us a decimal because 3 squared is 9 and 3 to the third is what, 21, 27, one of those. So it's going to be in between 2 and 3. So if we use our change of base, we're going to do log of 15, the big number on top, divide by log of 3, the little number on the bottom. And I'm going to show you that both of these get you the same answer. So I'm going to change this to a 15 and change my 4 to a 3. So using the change of base formula, we get 2.46. Okay. If I double checked with the other equation form, so this is log base 3 of 15. So there's the 15 and the 3. Well, see, that's, there we go. Will it work? Cool. So I went to ABC. I hit this AB button. It's right below the Z. It gives you a subscript. So I was able to change the 3 that way. Or you'd have to go back into functions and retype it. But you get the same number, 2.46. So both methods work. But again, change of base always works. Okay, we're going to do a few more here, and then you have a quizzes practice. So we have log base 3 of 6. So we would do log 6 on top, log 3 on the bottom. If we type that into our change of base formula here, 6 on top, 3 is going to stay. Our answer is 1.63. And if you wanted to check it with the other one, you should see that you get the same answer, 1.63. All right, let's do 4 and 6. We'll skip 5. So for 4, we would have log base 16, the big number, over log base 6, the little number. So 16 on top and 6 on the bottom. We have 1.54. Again, I'm not going to round. Okay. Trying number 6. So I've been saying the big number and the little number, not because 16 is bigger than 6, but because that number is written bigger. So for this one, again, the number on top is going to be the 2 because it's written bigger. And the number on the bottom would be 9 because that's your subscript. It's written smaller. Okay. So log 2 on top, log 9 on the bottom. This one is going to be 0.31. Okay. So hopefully mentally you can understand what a log is representing. But if you're having trouble figuring out 4 to what power is 16, we should know it's 2. You can always use your change of base formula or the special equation on Desmos. Okay. So go ahead and practice evaluating using the quizzes link on Canvas. Please insert your score here so that I can give you your points. If you give me an 80%, I'll give you an 80%. So you can take it as many times as you want to get the score that you are happy with. If you have any questions, let me know.